Hello and welcome back. Thanks for coming to the third video, watching the third video on this. I hope this means you're getting something out of this, and I hope I've got more for you to get out of this in the future. So first thing I'd like to do is take a look at what we covered in those first two lectures, sort of quick summary here. So first, we saw the rise of two great civilizations, Egypt and Mesopotamian civilizations. They basically were the definition of civilization in the area of the world we're looking at for thousands of years. And every other little civilization around had to define themselves, create their identity in relation to these two big giants. Other smaller civilizations were around too, of course. And also something is that their notion of magic and their perception on the world was very grounded. I mean, they did believe in what we would call magic and such, but it was about control of the world. It wasn't necessarily otherworldly. It was very practical. I heard somewhere that Egyptian priests didn't tend to people. Egyptian priests went and prayed in the temples to keep the universe running smoothly. They were kind of like workers at a power plant. I don't know how a power plant works, but if workers at a power plant can keep the power going, I'd be happy with that. And the priests in Egypt were responsible for going into the temples and by praying, keeping the world running smoothly. And so it's very, very worldly in that way. Then in about 1200 BC, there was the collapse of Mediterranean civilization. Egypt and the Mesopotamian civilization survived, but they were very sort of degraded. They did take a big hit. And then classic Greek civilization sort of came out of that dark age that followed the collapse of the 1200s. The occurrence of Iliad and Odyssey, the Trojan War and such happened, was supposed to have happened right before the Dark Age collapse or the 1200 collapse. It was written about by Homer right as the Greeks were coming out of the Dark Age that followed. All right, so hence we have the rise of this Greek world. So let's take a look at this Greek world again. All right, so now remember, Greek world was more than just Greece. They were seafaring people, and they had colonies and trading areas all over, from western Sicily over here to a lot along southern Italy, right along here. Of course, we got Greece right here. Greece was Greek, of course. And then the western edge of the Black Sea over there. That's the eastern edge. Yeah, that's the western edge of the Black Sea. And then the western edge of Anatolia here was very Greek. And also, these little islands out here were also Greek. And there was even a Greek city down here in Egypt. So all of this green area around here was really Greek at the time. This was sort of the extended Greek world. Then in about 800 BC, there was sort of a revolution in thought, which has been called the Axial Age Revolution since. Let's take a look at that. Well, the Axial Age Revolution was thought to have come out of, let's see, the black. Here about India and Iran, this area here is where the sort of new thoughts came along. These ideas of otherworldliness and universality and the persistence of one's identity even beyond their death. And these ideas progressed through classical Hinduism into India, and then up over to here with the founding of Jainism and Buddhism, around this way into China, which Confucianism, and it migrated westward here as well. And these new ideas came and took root in Western philosophy. And it was then that was the birth of, what we would consider Greek philosophy, Western thought, however we want to put that. Again, the characteristics was that this perspective, your perspective, philosophy, religion, whatever, was universal, that it was not tribal, that it was otherworldly for the first time. It wasn't just about taking control of this world. And finally, that we know these things by the continual persistence of our identity, which is really relies in our soul after death. All right. So now, this video is going to cover the Greeks that came before Socrates. And then the next video was going to cover Socrates, Plato, and Aristotle. And it was over this period of time that this whole axial age, innovation, revolution came about, and we'll see it unroll through the progression of Greek thought. In particular, when I start talking about Thales at the start, the first philosopher, he's not necessarily going to fit these characteristics of the axial age innovation that I talked about. So just remember, just from now on, when I'm talking about people, take them as I say, and I'll point out to you as these axial age innovations are unrolling in our story. All right. So first, let's take a look at Thales, when he lived and where he lived. Okay, so what I thought I'd do here is first show you a bit where we are context-wise. So this area right here is the Bronze Age collapse, all right? This is when the Iliad and the Odyssey were composed by Homer, and it describes events that were supposed to have taken place around here. And so then let's go ahead. This is right here at the edge here is 700 BC. So then let's go ahead. Now you can see this is really getting dense. This is all the Greek stuff, right? And I put some little reminders here. Here's 700 BC, here's 600. I put some reminders that these are the 600s, right? And so forth. Now, let's see, Thales, approximately over this period of time right here. Let's see, anything else to say? Oh, yes. Also, so if we take a look here, that was when he founded the Milesian school. It's good Miletus, where he was at. And over here is where you might be able to read this. It says, Miletus crushed. It's where the Persians sort of sacked Miletus. So this was the extent of his school here. This was the duration of his school. And just put in a little context here, down here, this dot around here is the foundation of philosophy in Athens by Anaxagoras. All right. So Thales did his work in Western Turkey in a place called Miletus, which is probably around here. Now, something to know about Turkey is that it's got like a mountain range in this area there, which really breaks it up into sort of an interior highland plain area, which at the time was Lydia, the country of Lydia. They were the first country to mint coins. They were known as being very wealthy. You might have heard of Croesus, the phrase rich as Croesus. Croesus was a king in that area. And then on the other side of the mountains was the low coastal area. And as you can see by the green coloration here, the low coastal area was Greek. Right? That's what green means, it's Greek in here. So Thales was a merchant, and he traveled from there to Egypt, and from Egypt to Mesopotamia, and from Mesopotamia back to Miletus, where he founded a school. And that's how he could establish his credibility as a serious thinker. He had visited and learned all the learning there was to have in the two great civilizations of the time. All right, now, what was he known for? Okay, so what was he known for? The first idea was that through common observations anyone can have, and then a line of reasoning through it that anyone can follow, you can uncover some hidden knowledge, some truth that wasn't apparent at the start. So here's a classic example from Thales. You watch a cow. Cow is eating grass. And then a while later, someone milks the cow and gets milk out of the cow. Well, you don't think stuff just vanishes into nothing, and you don't think material stuff just appears out of nowhere. And so that means that milk must have come from somewhere. The stuff the milk was made of must have come from somewhere, and the obvious conclusion is it came from the grass. So that is that the substance that the milk is made up of must have been the same substance that the grass was made up of. It just got transformed into a new form. So that things that look different, smell different, taste different, have different properties, might actually be made of the same substance, that there's this sort of common underlying thing. From that, Thales concluded that everything was made of the same substance. And what was that substance? Well, he concluded water. Why water? Well, obviously there's a lot of water in living things. And even things that aren't living might have some water in them as well. Water, we can easily see how it can change from a solid to a liquid to a gas. So it's very transformable. And also he had discovered some fossils of fish or shellfish or such in higher mountain areas where there was no water around, leading him to conclude that there used to be a lot more water in the world than there was now. And so his thing was everything is water, was his conclusion, which he believed he came from just common observations anyone can make and a common reasoning on these observations. Something else he was known for, another innovation he was known for, was mathematical reasoning. He was the first one to give a mathematical proof. So let's take a look at what it was he proved. I'm not going to prove it, but we're going to take a look at what it was he is said to have proved. All right, so what he proved was this. Take a semicircle, half circle, and now take a triangle whose one edge lays along the diameter of the semicircle and whose opposite corner lies somewhere on that semicircle like this. All right, if you construct a triangle in such a way, it will always be a right triangle, and that angle there will be a right angle. Ta-da! The first thing actually proven. And he got the ball rolling on mathematical proof. Here's the idea. So, as I said, he founded a school of thought in Miletus, a school of philosophy, if you will. And then there's a lot of Milesian, from that time, it was a bunch of Milesian philosophers. Now, they argued, of course, that's what philosophers do. And they argued about what the world was made of. It's made of water. It's made of air. It's really made of fire. But there were a few things that they all sort of bought into. They all bought into this method of just making common observations and reasoning off of them can discover some sort of hidden knowledge. And also they valued mathematical reasoning and proof and developed that sort of idea there. Okay, so that's sort of what Thales brought in, where and when. Now let's take a look at Pythagoras. So let's go to the timeline and see around when he existed. So now we'll talk about Pythagoras. Here again is the Greek timeline we were looking at earlier. And Pythagoras is somewhere around here. So this is when he lived, and then that's when he started his school, and it persisted on from here for quite some time. Pythagoras is originally from an island called Samos off the Greek coast, like around there. And the story has it that he had to flee rather quickly. He got into some kind of trouble with the local tyrant. And if you get in trouble with a tyrant, the best thing to do is just leave. After he left, he went on a lot of travels. And of course, it was said he traveled to Egypt. He traveled to Mesopotamia, not necessarily in that order. He learned what there was to learn there. And then in the end, he came all the way back and settled on southern Italy at a place called Croton and started up a school of philosophy / mystic religion. Now, apparently, he got into some political trouble again. There was a hullabaloo, and his school was burned to the ground, at which time they relocated to the other side over here. That's probably not even easy to see, at a place called Metapontum, where he started his school. And it's at Metapontum, which over 100 years later, Plato was a slave of the tyrant Archytas, who was a Pythagorean, and that's where Plato was exposed to the ideas of Pythagoreanism. So we have them to thank for that. All right, so now, what was Pythagoras up to down there in southern Italy? Now, as we said earlier, the Milesians were arguing what was the world made of, a big debate. And Pythagoras came up with an answer that stood out, even for the time, was a little unusual even for the people we're talking about, and that is that everything is number. What could he mean by that? I don't know. Nobody really knows, but we can make some speculation. Before we get into speculation, however, now would be one of those times I'd like to point out that, connecting back to the last lecture, this is when we start seeing some early axial age innovations coming in, ideas of abstractness. By number, he means some kind of abstract entity, otherworldliness, and he also talked about reincarnation, which was a new idea in the area at the time, which is why people speculate that in his travels he might have run into Hindu travelers, merchants, whatever. So, but let's get back to what could he have meant by number? Well, nobody knows really, but we do have a couple speculations. So let's take a look at what are some things he could have meant by number. Let's get a, oops, move this around here. So first of all, what does he mean by number? So there is some reason to believe that by number he meant points in configuration. So for example, 1 can be represented by a point. We could represent 3 by 3 points like this. We could represent 6 by 6 points like this. And notice what I'm doing here is each time I'm adding on another layer to this triangular. 1, 3, 6, and 10 were all called triangular numbers. So numbers, 1 minute, did not have an independent existence just as numbers as we think of them, but were thought of as points in configuration. This is also where we can get square numbers. 1, 4, 9. If we can arrange points into square configurations like this, we would get square numbers. So one possible thought of what he meant by everything is number is that everything is points in configuration, that this might have been an early form of atomism, that points were like atoms and their spatial configuration determined all of their properties. So that's one thing he could have meant. Something else is he was very impressed with some surprising ways that numbers came up. So for example, let's take a look in music. If you have 2 chords and one is twice as long as the other, and we pluck them, then they are in a harmonic relation. If we have 2 chords, however, and one is, let's say, 15/13 the length of the other, then they are dissonant. That is, if you have 2 chords and their ratio is in small whole numbers, then it is harmonic. And if you have 2 chords and their ratio is in large numbers, one written in simplified form, of course, then it is dissonant. And so here's a surprising way numbers can come up in, say, music. And that impressed him so much that he sort of concluded that everything must underlyingly be affected and impacted and governed by numbers in some sort of more mystical, not quite as thought out way. So that's something else he could have meant. One is. The important thing is that he supposedly achieved all this through his mysticism, through sort of rational thought, and he valued mathematical proof. And the Pythagoreans in southern Italy continued to do mathematical proofs and further mathematical proofs. All right. So if we could think of anything, he said, we could count it. Maybe this is where numbers came from. You know, if you could think of things, you can count them. And so anything that was infinite was unthinkable. It was irrational. It was crazy. It didn't belong. And we had to avoid infinities by any way possible. So this became a big sort of part of his philosophy and definitely progressed throughout Western thought for a long time. Now, let's take a look at some of the principles. So let's take, so you can get a sense of, despite what I've said, how more or less scientific sounding they can be. So I'm just going to list some Pythagorean principles here. All right, let's take a look at some Pythagorean principles. First of all, space is made up of points and time is made up of instances. All right, here's another principle. You can only cross a finite number of points in a finite time. Sounds reasonable. Things can either be moving or stationary, but not both at the same time. Okay. Every 2 points has a unique midpoint. So like if we have a point here and a point here, boom, they have a unique midpoint. So far, so good. Doesn't sound bad. This is going to cause them problems. They're going to run into problems with this. How are they going to run into problems? All right. Well, the next philosopher we're going to look at is sort of a pair. There's a philosopher named Parmenides, and he had a student named Zeno. Now, I'm not going to take you to the timeline for this because at this point my timeline's kind of crowded and hard to make out and such, so you're not going to get a lot out of looking at that. But suffice it to say, they're contemporary with each other. Zeno's a student of Parmenides, and they both lived around the time that that Miletus was sort of sacked by the Persians. So the end of the Milesian school I talked about last time or 2 times ago that we looked at the timeline. All right, so Parmenides operated out of Elia, which was a city, again, on the Sol, the bottom part, the Greek part of Italy, near Croton and Metapontum. He taught that all was one, that time was an illusion, that change was an illusion. He was kind of, by some people, mocked for these principles. Zeno was a Pythagorean at Metapontum, and he eventually left Metapontum and went to Elea, studied under Parmenides, became a follower, and then from there went to Athens. At Athens, he got a lot of flack for the Parmenides belief, but Zeno had the last laugh because he said, listen, you Pythagoreans, you're making fun of me, or you're making fun of my master for all of these crazy stuff, but your very principles prove it. Let me rigorously prove his principles, his theory from your own principles. Let's see how that goes. So we'll give three sort of proofs that change is impossible, change is an illusion, everything is one, so on and so forth. All right, how does that go? Okay, so the first, these are known as Zeno's paradoxes. The first paradox, there we go. The first paradox is called From Elea to Athens, E-L-E-A, Elea to Athens, of course, named after where Zeno was from and where he ended up at. So let's say Zeno wants to travel from Elea to Athens. Now, one of those Pythagorean principles was you can only travel through a finite number of points in a finite time. So here's a question. How many points did he travel through? Well, the last principle said that given any 2 points, Elea and Athens, there's going to be a unique midpoint. So let's say right here, here's the midpoint. So that's at least 1 point he had to travel through. Now, if he's here at this point, still before he gets to Athens, he has to travel through another midpoint right here. So that's at least 2 points he has to travel through. Also, even to get to this midpoint from Elea, he had to travel through a midpoint between those two. So that's a 3rd point he had to travel through. Now, let's say we want to speculate, he has to travel through 100 points. We can repeat this argument again and again and again and again and get over 100 points. Okay, let's say he has to travel through 1,000 points. But we can repeat the argument again and 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 get over 1,000 points. In fact, any number you give me, he has to travel through more than that number of points. Therefore, for Zeno to get to Elea to Athens, he had to travel through infinitely many points. And by the principle that says you can only travel through finitely many points in finite time, he can't do it. And so his whole travel from Elea to Athens must have been an illusion. And in fact, there's nothing special about Elea and Athens. This could argue that you can't walk across the room. All right, well, got a problem with this? Tell me what the flaw in the argument is. Okay, the next paradox is Achilles and the tortoise. And this is just a variation on what we just saw. So Achilles is the swiftest of the Greeks, and he's going to race the tortoise, which is the slowest of the animals. Now, being a sporting fellow, he's going to give the tortoise a head start. So there's the, well, I guess they don't have guns in ancient Greece, but whatever, they say go. And quickly, Achilles covers the distance from where he started to where the tortoise started. And in that time, the tortoise traveled a very little bit like that because the tortoise is slow. So here is, Achilles has to travel past the point where the tortoise started before he could catch up to the tortoise. Now he real quickly covers the rest of that distance, but in that time, the tortoise again travels a very slight distance very slowly. Well, he has to again travel through the point that the tortoise was when he reached the tortoise's starting point. And again, we can iterate this argument again and again and again to argue that Achilles has to travel through infinitely many points before he can reach the tortoise. So therefore, again, by the Pythagorean principles, he should not be able to pass the tortoise. So motion is actually impossible. It's an illusion. Motion is an illusion. All right, the last one's slightly different. Let's say we're firing an arrow at a target. So we got a guy here, bow and arrow, we got a target right here. We fire the arrow, and imagine the arrow at the instant it passes the halfway point. Halfway isn't important in this one. So imagine the arrow at that instant in time. Okay, picture it at that instant in time. Time is made up of instants. How fast does the arrow travel? Well, at that instant in time, the arrow doesn't cover any distance. So it's not actually traveling at all. So at that instant in time, it's stationary. Well, imagine it at the instant in time when it's right here. So picture it at that instant in time. Again, at that instant in time, it's not covering any distance at all again. So at that instant, it's stationary again. In fact, we can repeat this argument and get that at every instant in time between when the arrow leaves the bow and reaches to the target, that arrow is stationary. But one of the Pythagorean principles is nothing can be both stationary and moving at the same time. So the arrow must not have really crossed the distance from the archer to the target. So there you go. All right. This is why the Pythagoreans hated infinity. And this is why they said avoid it at all costs. Now, we're going to see in the next lecture that Socrates has a solution for this. Historically, some people have found it somewhat unsatisfying. And then much later in this series, once we learn calculus, we're going to hear some actually much better solutions. I love teaching this stuff in calculus class because I see there's one instance where you learn math in a math class and it can actually solve these weird philosophical principles. A real nice use of mathematics, but that's down the line. Give you some motivation to keep watching these videos. But now we've finally reached Greece and Athens. So notice, as I had said earlier, here's one important thing, or one interesting thing, that none of this philosophy and all this stuff going on so far actually happened in the Greek heartland. We had the Greek world, and all of these innovations occur in the outer lands, in the hinterlands, where different cultures are meeting, and there's a lot of a flow of ideas. That is now going to change. Now we are going to go to the heart of the heartland, Athens in Greece, and see the dawning of the philosophical school there. We're going to look at Socrates, Plato, and Aristotle, and see how they reacted to / addressed / used all of these issues, all of these thoughts that we've been talking about so far. So I look forward to seeing you then. Thanks for watching again.